Hello and welcome to How to Econ. Today we will take a look at the definition of price elasticity, its formula, and its applications. Before we get to the technical part, let's take a look at a story about EpiPen. EpiPen is a medical device to inject a measured dose of epinephrine to treat symptoms of severe allergies. Since 2007, EpiPen belongs to Mylan, an international pharmaceutical company based in Pennsylvania. Mylan outraged consumers and lawmakers by ruthlessly hiking the price of its EpiPen by more than 400%, from about $100 to slightly over $600 for a box of 2 EpiPens between 2012 and 2016, right before a generic competitor reached the market. This is about $500 increase in the price of a box of EpiPen without any improvement in the quality. The move boosted Mylan's profit to more than $1.1 million. This action of Mylan highlights a common tactic in the drug industry, which is sharply raising prices in the years just before a generic competitor reaches the market, as a sort of final attempt to milk big profits from the brand name drug. Patients did not have many choices at that time because it was an essential device for their medical condition, which could be life-threatening, and Mylan was controlling about 90% of the market. As a result, even though the price of EpiPen increased significantly, their revenue didn't decrease because consumers still have to buy the pens. This is an example of price elasticity. Price elasticity measures how much quantity responds to a change in price. Quantity demanded for EpiPen changed just a little, if at all, in response to the change in price. In economics, we say that EpiPen customers were not sensitive with respect to the change in price because they need the product and they did not have many alternatives. We also can say that demand for EpiPens is not very elastic, or demand for EpiPen is inelastic. Let's take a look at another example. This one is about Netflix, the movie streaming service. In 2011, Netflix split its DVD and streaming services into 2 different subscriptions. Customers who want to use the DVD service only had to move to a new website called Quickster, which belonged to Netflix, but it looked like it was a whole new company, which required customers to set up a new account again. If Netflix members wanted to continue with the combo of both services like they had before 2011, they had to pay an extra $6 in monthly subscription fee. $6 extra per month might not sound too big to you, but this small increase in the subscription fee led to 800,000 subscribers canceling their Netflix services. This is an example of elastic demand. That means consumers are very sensitive with changes in price. A little change in the price led to a significant change in quantity demanded. In this case, a little increase of $6 per month in the price led to a drop of about 800,000 customers. Netflix customers are more sensitive to changes in price than EpiPen's customers in the first example because watching Netflix is a luxury or an entertainment. It is not essential or important for a person's survival. Moreover, when Netflix price increased by only $6 per month, people easily dropped the service because there were many other ways to entertain besides watching Netflix. What we have so far are 2 examples of price elasticity. It measures how much quantity responds to changes in price. The concept of price elasticity can be applied to either supply or demand. If consumers have low responsiveness to price changes, that means we have inelastic demand, like the case of EpiPen. If sellers have low responsiveness to price changes, that means we have inelastic supply. Here is an example of inelastic supply. Airbnb is a service that allows people to have extra rooms or extra houses to rent them out to other people for a short time period. During the corona pandemic, the price of Airbnb rooms or places plummeted. but their owners still offered Airbnb services because they probably cannot sell off their properties quickly and they need the revenue from those properties. In economic terms, we say that the quantity supplied did not change much, or sellers had low responsiveness to changes in price. It's the same with saying the supply is inelastic. On the other hand, if consumers have high responsiveness to price changes, that means we have elastic demand, like the case of Netflix. If sellers have high responsiveness to price changes, that means we have elastic supply. For instance, basic facial masks are not too difficult to make. When the pandemic hit us, people were willing to pay higher prices for basic masks, from a few cents to a few dollars. Many people immediately produced homemade masks and sold them for profit. In economic terms, we say that the quantity supplied changed quickly with a little change in price, or sellers had high responsiveness to changes in price. It's the same with saying the supply is elastic. Now, as we know what price elasticity means, let's take a look at how to calculate price elasticity. First, I will explain the formula, then we will do two numerical examples to help you understand the formula better. As you can see from the slide, price elasticity equals percentage change in quantity divided by the percentage change in price. Please keep in mind that we are using absolute value only because we want to focus on the magnitude of the change, not the negative or positive sign. If we have to calculate price elasticity of demand, we will divide the percentage change in quantity demanded by the percentage change in price. If we have to calculate price elasticity of supply, we will divide the percentage change in quantity supplied by the percentage change in price. How do we calculate the percentage change in quantity? We have the formulas on the screen here. Assume P1 and Q1 represent the old price and old quantity levels. P2 and Q2 represent the new price and the new quantity levels. To get the percentage change in quantity, we take the new quantity level Q2 minus the old quantity level Q1, then divide the result by the average of Q1 and Q2. The average, or the middle point between Q1 and Q2, is calculated by Q1 plus Q2 divided by 2. Similar formula is used to calculate the percentage change in price. We take the new price level P2 minus the old price level P1, then divide the result by the average of P1 and P2. The average, or the middle point between P1 and P2, is calculated by P1 plus P2 divided by 2. Mathematically, these formulas measure the percentage change of price or percentage change of quantity with respect to the middle point between two price levels or between two quantity levels. That is why this method is called the midpoint method. The advantage of the midpoint method is that one obtains the same elasticity between two price points, whether there is a price increase or decrease between those 2 points. After we calculate price elasticity, if we get price elasticity larger than 1, that means the percentage change in quantity is larger than the percentage change in price. That means we have an elastic demand or supply. Since revenue equals to price times quantity, if demand is price elastic, an increase in price will lead to a decrease in revenue. This is because the decrease in quantity demanded is larger than the increase in the price, and it will bring the revenue down. But when demand is price elastic, a decrease in price will lead to an increase in revenue because the increase in quantity demanded is larger than the decrease in price, and it will boost the revenue up. Therefore, if you are a business owner and you realize that the demand for your product or service is elastic, that means your customers are sensitive to the change in the price, you might consider decrease your price instead of increase your price to gain more revenue. On the other hand, If the price elasticity is smaller than 1, that means the percentage change in quantity is smaller than the percentage change in price. We have an inelastic demand or supply. In this case, even if the price increases significantly, quantity demanded does not decrease too much, then revenue will go up with price. And when price decreases a big chunk, quantity demanded does not increase much. As a result, revenue will fall with price. If the price elasticity is exactly 1, that means the percentage change in quantity is exactly the same with the percentage change in price. We have an unitary demand or supply. In this case, changes in price will probably not change revenue because any change in price is compensated by exactly the same change in quantity. Let's do 2 numerical examples to help you practice the price elasticity formula. First, we will use the midpoint method to calculate the price elasticity of supply between points A and B in a rental market and see what category of elasticity does the result falls into. At point A, the price level P1 equals $650 per unit and the quantity level Q1 equals 10,000 rental units. At point B, the price level P2 equals $700 per unit and the quantity level increases to 13,000 units. This reflects the law of supply that we know from the first day of any economics class. It says, all else equals, when price increases, quantity supplied increases. Let's calculate how sensitive the sellers are with respect to the change in price here between points A and B using the midpoint method. Thanks to the midpoint method, it doesn't matter whether we are changing from point A to point B or from point B to point A. We should get the same answer for price elasticity of supply. If you want to try it by yourself, please pause the video now. Otherwise, keep watching. First of all, we will calculate the percentage change in the quantity supplied. Then we will calculate the percentage change in the price. Finally, we will apply the formula for price elasticity to calculate the elasticity between point A and point B. To calculate the percentage change in the quantity supplied, we take the new quantity level Q2 or 13,000 rental units minus the old quantity level Q1 or 10,000 units, then divided the results by the average of those two quantity levels. As you can see on the screen here, we get the percentage change in the quantity supplied is 21.6%. Now, to calculate the percentage change in the price, we take the new price P2 or $700 minus the old price P1 or $650, then divided the results by the average of those two price levels. As you can see on the screen, we get the percentage change in the price is 7.4%. Remember the formula for price elasticity? You divide the percentage change in quantity by the percentage change in the price. So we take 26.1% divided by 7.4%. We get the price elasticity is 3.53, which is larger than 1. Therefore, the conclusion is the supply is elastic between points A and B. So what exactly does the number 3.53 mean? When we say a price elasticity is 3.53, that means if price changes by 1%, quantity level will change by 3.53%. In this example, we can say that between points A and B, if price increases by 1%, quantity supplied will increase by 3.53%. If price decreases by 1%, quantity supplied will decrease by 3.53%. Alright, that was easy. Let's take a look at another example. This time, it is for the demand side. Assume that we have a demand curve for shoes here. We will use the midpoint method to calculate the price elasticity of demand between points A and B on the graph, and then decide what category of elasticity does the result fall into. At point B, the price P1 is $70 per pair of shoes, and the quantity demanded Q1 is 2,800 pairs. At point A, the price P2 is $60 per pair of shoes, and the quantity demanded Q2 is 3,000 pairs. Remember that thanks to the midpoint method, it doesn't matter whether the price is going up from point A to point B or going down from point B to point A. The price elasticity of demand is the same. If you want to try it on your own first, then please pause the video now. Otherwise, keep watching. First of all, we have to calculate the percentage change in quantity demanded. Assume we are moving from point B to point A, so the old quantity level at point B is 2,800 pairs of shoes, and the new quantity level at point A is 3,000 pairs of shoes. Notice that this increase in the quantity demanded when the price goes down reflects the law of demand. Anyway, to calculate the percentage change in quantity, we take the new quantity level 3,000 minus the old one 2,800, then divide the result by the average of those two quantity levels. As you see on the screen, we get the percentage change in quantity is 6.9%. Now, we need to calculate the percentage change in price. We take the new price $60 minus the old price $70. Then divide the result by the average of those two price levels. We get the percentage change in the price is 15.4%. The negative sign you see while calculating percentage often means a decrease. However, as I mentioned earlier, we only care about the magnitude of the change, not the sign. So in this example, we only care about the fact that the price has changed by 15.4%. Finally, to get the price elasticity of demand, we divide the percentage change in quantity demanded by the percentage change in price. So 6.9% divided by 15.4%, the answer is 0.45, which is smaller than 1. Therefore, the demand is inelastic between point A and B. You might ask again, what exactly does the number 0.45 mean? When price elasticity is 0.45, it means that if price changes by 1%, quantity level will change by 0.45%. In our example, if price decreases by 1%, quantity demanded will increase by 0.45%. And if price increases by 1%, quantity demanded will decrease by 0.45%. The increase in price is larger than the decrease in quantity demanded in this case, and your revenue would increase with the price as mentioned 4 slides ago. Now, as you know what is price elasticity and how to calculate it, let's see how we depict it on a graph. We will ignore all the mathematical calculation for now and just focus on the drawing on a graph. If a curve is relatively steep, that means it is inelastic. If a curve is relatively flat, that means it is elastic. As you can see on the screen, the supply curve in the first graph is steeper than the supply curve in the second graph. That means the first supply is less elastic than the second supply. Assume we have an increase in demand in both graph 1 and graph 2. It is easy to see that the same shift in demand from D1 to D2 can lead to a bigger increase in price and smaller increase in quantity when supply is inelastic compared with when supply is elastic. The demand curve in the third graph is steeper than the demand curve in the fourth graph. That means the demand in the third graph is less elastic than the demand in the fourth graph. Again, assume we have a same shift in supply in both graph 3 and graph 4. There is a bigger change in price and smaller change in quantity when demand is inelastic. In conclusion, in a demand and supply graph, if you see a curve relatively steeper than another curve, that means that side of the market is less elastic than the other side of the market. We care about this because it can help us answer questions such as what happened to a market when there is a tax, or who really pays for a tax. Before looking at a numerical example, let me introduce you to a new economic term under this topic of tax and elasticity. It is tax incidence. Tax incidence is the manner in which the tax burden or tax revenue is divided between buyers and sellers. If demand is more inelastic than supply, consumers bear most of the tax burden. That means most of the tax revenue for the government comes from consumers. If supply is more inelastic than demand, sellers bear most of the tax burden. That means most of the tax revenue for the government comes from sellers. In both graphs on the screen, we have a market for some product. We have the supply curve upward sloping and the demand curve downward sloping. They cut each other at point E. That is the original equilibrium of the market with the equilibrium price PE and the equilibrium quantity QE. The distance between point A and B depicts the tax per unit. I put the link for the tax video in the description just in case you want to review it. The graphs in this screen are similar with the graphs in that video. There's no need to draw a new supply or demand curve with tax like we did in that tax video, because we only care about the magnitude of the tax, which is the distance between points A and B, and how it affects the market. The distance between points A and B is the same with the distance between PC and PP. PC stands for the price that consumers have to pay after the tax. A quick reminder that in economics, consumers and buyers are used interchangeably. PP stands for the price that producers really receive after the tax. When a tax is applied, the price that consumers or buyers have to pay for the same product has increased from PE to PC. But remember that this price PC is not what sellers can keep for themselves. Sellers or producers have to subtract the tax from PC and give the tax money to the government. What the producer have left after that is only PP, much lower than PC. Again, the distance between PC and PP represents the tax per unit, and it is the same with the distance between A and B. In the first graph on the left, we have a supply curve that looks relatively steeper than the demand curve. That means producers are less sensitive to the change in price than consumers in the first graph. In the second graph on the right, we have a supply curve that looks relatively flatter than the demand curve. That means producers are more sensitive to the change in price than consumers. Let's look at each graph closely. Here is the first graph in which we have elastic demand and inelastic supply, or a relatively flat demand curve and a relatively steep supply curve. When there is a tax on their product, the price can increase a little but not too much, because producers know that their consumers are sensitive to higher price. Producers will try to bear most of the tax burden so that they don't lose too many customers. Therefore, the distance between PC and PE, which represents the increase in price for consumers, is much smaller than the distance between PE and PP, which represents the decrease in price for producers. The purple rectangular represents tax revenue. Tax revenue equals tax per unit times the quantity that is being taxed, which is QT in the graph. A big chunk of tax revenue in this case is contributed by sellers, and a small part of it is contributed by buyers. So we say that sellers bear most of the tax burden. Here is the second graph in which we have an elastic supply and inelastic demand. That means we have a relatively flat supply curve and relatively steep demand curve. When there is a tax on the product, the price can increase significantly and consumers still buy it. Think about the example of alcohol. People who are addicted to it will buy it even though if it is expensive. In this case, for each bottle of alcohol, sellers will increase the price as much as possible to compensate for the tax they have to pay back to the government. So the price that consumers have to pay increases from PE to PC. The price that producers really get is PC minus the tax per unit. So producers get PP. The increase in consumer price is much larger than the drop in producer price. Tax revenue, represented by the purple area on the graph, mainly comes from consumer contribution, and a small part of it comes from producer contribution. Therefore, we say that consumers bear most of the tax burden. Now let's try a numerical example. Assume we have a market for burgers here. The demand curve is slightly steeper than the supply curve. It hints that consumers are relatively less sensitive to changes in price than sellers. At the equilibrium, the price is $8 per burger and the quantity is 50 burgers. That means at the equilibrium E, consumers pay $8 for a burger and sellers keep that $8 for themselves. The vertical distance between point A and B represents a tax in the market. We will see who pays the bigger part of the tax and calculate the tax revenue. If you want to try it, please pause the video now. Otherwise, keep watching. First of all, the distance between points A and B is 12 minus 5 equals $7. That means the tax per burger is $7. Let's ignore how ridiculously high this tax is on a burger and just focus on practicing tax incidence here. Because of the tax, burger price increases from $8 to $12 for consumers. Consumers now have to pay up to $12 for a burger. So the price has gone up by $4 per burger for consumers. They buy less burgers at this higher price. The new equilibrium quantity is 35 burgers. However, sellers do not benefit from this higher price. Remember that sellers collect $12 per burger, but they have to extract $7 tax out of that and give it to the government. So what sellers are left with after paying the tax is $12 minus $7 equals $5. Compared with what sellers got before, which was $8, sellers lost $3 because of the tax. So for each burger, there's a tax of $7. Out of this $7, $4 come from consumers and $3 comes from sellers. Consumers bear a bigger tax burden in this example. It is because the demand is more inelastic than the supply. Tax revenue equals the tax per unit times the quantity being taxed. The tax per burger is $7 and the quantity being taxed is 35 burgers. We have the tax revenue is 7 times 35 equals $245. Out of this $245 tax revenue, consumers contribute $140. You take 12 minus 8 times 35 to get $140. Out of the $245 tax revenue, sellers contribute $105. To get that, you take 8 minus 5 times 35. One more time, we see that consumers bear a bigger tax burden than sellers. Let's take a look at one more numerical example. Assume that we have another market for burgers here. The original equilibrium is point E. The equilibrium price is $6 per burger. The equilibrium quantity is 2 burgers. The distance between points A and B represents a tax. That means the tax is $5 per unit. You take the price at point A, which is $9, minus the price at point B, which is $4. You get the tax of $5 per burger. Let's practice what we know about market efficiency before and after a tax. We will calculate consumer surplus, producer surplus, total surplus, tax revenue, and deadweight loss before and after the tax. If you want to try it by yourself, please pause the video now. Otherwise, keep watching. Before the tax, Consumer surplus is the triangle above the equilibrium price and below the demand section above the equilibrium price. So it includes the area C, D, and H. Assume they are combined into a triangle. Using the triangle area formula, you can get consumer surplus equals 6. Before the tax, producer surplus is the triangle beneath the equilibrium price and above the supply section below the equilibrium price. So it includes the areas F, K, and G. Assume they are combined into a triangle. Using the triangle area formula, you can get producer surplus equals $4. Before the tax revenue is 0 and there is no deadweight loss. In this case, the total surplus equals consumer surplus plus producer surplus, and it equals 6 plus 4 equals 10. Because of the tax, the price that consumers have to pay for the same burger has increased from $6 to $9 per burger. They now buy 1 burger instead of 2. However, out of this $9, sellers have to pay $5 tax back to the government. What the sellers have after paying tax is only $4 per burger. So you can see that the price for consumers has increased by $3. The price for sellers has decreased by $2. That means out of $5 tax per burger, consumers bear $3 and sellers bear the other $2. Consumers bear more of the tax burden per burger than sellers. This hints that consumers are less sensitive with respect to changes in price than sellers. This dynamic also creates new consumer surplus and new producer surplus. New consumer surplus is the area C only. New producer surplus is the area G only. Assume they are triangles. You can calculate them using the numbers on the graph and the formula to calculate the area of a triangle, height times base divided by 2. Triangle C's area is $1.5 and triangle G area is 1. So consumer surplus decreases from $6 before tax to $1.5 after tax. Producer surplus decreased from $4 before tax to $1 after tax. Tax revenue equals the tax per unit times the quantity being taxed. In this case, the tax revenue will be $5 times 1 equals $5. In the graph, it is represented by the combination of the areas D and F. Out of this $5 tax revenue, the area D is contributed by consumers, which is $3, and the area F is contributed by sellers, which is $2. Remember, D was a part of consumer surplus before tax, and F was a part of producer surplus before tax. Again, we can see that consumers bear the bigger part of the tax burden than sellers. It is because consumers are less sensitive with respect to a change in price. Finally, the deadweight loss is the combination of the areas H and K. Assume that it's a triangle again. We can calculate its area directly. It is $2.5. There is another way to calculate the deadweight loss. Remember that by definition, it is a decrease in total surplus. We can simply take the total surplus before tax minus the total surplus after tax. So it is 10 minus 7.5 equals $2.5. There you have it, the connection between market efficiency, taxes, and elasticity. Thanks for watching, guys. That's good for now. Take care and see you in the next video.